So hi, I will present myself a bit more in details. So yeah, I'm Guerric I was part of the Enjmin as in the P16 as a sound designer, and I completely switched from wanted to really go hardcore in the code and learn more and more into the about the low-level programming. So I did my end of the year internship at the INA-GRM, which is like a research center for experimental music in Paris, and learned a lot about like low-level programming, so like C++, and also a lot of DSP stuff. And then a bit of freelance work, building some plugins, audio plugins. And then I just sent my CV everywhere. I wanted to move abroad, and Impulse Audio Lab replied. And now I work for them since 3 years as a audio embedded software developer. Really long name for just making vroom vroom, basically. All right, so today's topic is the automotive audio. So it's quite a known topic, as there are not that many resources available, actually. So I'm glad to be here. Thanks all the EGC team to talk about it. Let's get into it. Let's start with a bit of history. Ooh. All right. So I tried to find when did it started to have some people that tune the cars to have better sound, and I could not find anything, basically. I just found some facts about, like, for example, Ettore Bugatti, the guy that created the Bugatti company, that was apparently obsessed with the sound of his cars and probably tuned the sound of his engine so it sounds great. And yeah, in the history later, all the cars started to try to bring their own unique signature sound, like every models have this kind of particular sound. For example, the Porsche 911, so the one here, that has kind of a characteristic sound, and it's mostly due to the intake and the exhaust. Like the way the engineers tune the exhaust is particular and make a specific sound, and it's here only for the sound of it, not for the performance. So I have some examples of, like, you will hear that there are not that many difference, and these two cars have like 20 years, more than 20 years of difference, but they sound kind of similar. All right. Okay. So that's the 1978. And then the 2004. More powerful, but some kind of similarities. So if you don't really work in the automotive industry, probably you don't know the difference, but I can tell it. Then, later in the history, people started to think more about the user experience as a driver and the sound of the engine, like, and not as a pragmatically thing that is here, but more like finding ways to have it sound better in the interior and not only in the exterior. And for example, there is this thing from Porsche again called the Symposer, sound Symposer, which is some kind of tube that goes from the engine to the interior that obviously filter all the gas and everything. It's just here for the sound, so it sounds better in the interior. Then increase the proximity between, like, the driver and the engine, and creates a better user experience. Now for the modern days, I mean, it's kind of the same for the combustion engine sound, but some brands started to be limited in terms of the sound that they can do, and also the size of the engine and the consumption of the engine. So they started to use different technologies. Like the first one would be it's called the ANC, which is active noise control, or there is also the RNC, which is the road noise reduction. And it's basically the same as these earphones that you have on your head that reduce the noise. It's the same, like it will have microphones outside, capture the sound, and then invert the sound wave, and then inside the car, the noise level of the roads is limited. And another thing that they started to develop is something called the active sound design, the ASD, and basically one part of that, so sorry, it's a lot of ASD, ESE, I mean a lot of three-word thing, and it's everywhere in the automotive industry. It's really hard sometimes to know what everything means, but I will go back to that later. So part of the ASD, the active sound design, is a ESE, which is engine sound enhancement. So basically some engines were not sounding as good as it was in the past for, as I said, like the engine cannot be too big or it cannot consume enough, so the sound is different. And to make better sound, they basically capture some inputs from the car, like the RPM or the speed, whatever, and add some harmonics to the sound of the engine, so it sounds more aggressive. So I have a... Okay, so... That's the BMW M2 without this technology, and then with, okay, I will maybe put the one again, and then the one with the active sound design on. So that's without, and that's with. Okay, I swear there is a difference. It's mostly in the low frequencies actually. So, but yeah, if with headphones or things like that, you really hear it, and when you experience it, there is actually a difference. But yeah, here maybe not. Okay, yeah. Then what about the electric vehicles? So the electric vehicles have basically the engines are too quiet, and it basically doesn't produce any sound in the exterior of the car. So you have to create some synthetic sounds outside, so that I mean, I will go back to this why afterwards, but basically because for safety reasons, you don't want anyone that has that is blind or people that cannot see the car to be, yeah, I mean, basically don't listen to the car and get hurt. So there are some legislations, legal stuff where they have to produce some sound outside. So maybe a really common one that you probably know and have listened, it's the Renault Zoe. So all of these sounds are synthetic. Everything is coming from speakers that are in the car. Then a more modern one, the BMW iX M16. I think Hans Zimmer did the sound of this one. Yeah. Yeah, it's an ad, so, but whatever. Yeah, the spaceship sound. Yeah. Then another example of synthetic sound is a project that my company worked on, because my company is split in two parts. There is the software development part and the sound design part. And we work on customer projects, but also on our own project called the EVX that I will show afterwards. And this was a customer project for Mercedes G. and it's an all electric, yeah, super big ass car. And they wanted something that sounds more like the combustion engine, so a bit less spaceshipy, more, yeah, vroom vroomy. All right, so now let's go a bit deeper into the technical stuff. Okay, so there is a lot, as I told you, a lot of 3 letters things. You don't have to know any of these. And yeah, I defined some stuff before, but basically automotive audio means a lot of things. It can be like the loudspeaker system, the engine sound, what we call the infotainment systems, which is basically the radio, the GPS voice, the phone, the UX sound, the ADAS, which is all the warnings and alerts that you get if you are parking, or yeah. And then there is another part, which here I call the sound management and acoustic enhancement, which englobes basically the more interactive audio systems between the user and the vehicle when you are driving. So for example, the the ASD, which is the active sound design, which I showed previously. So basically the synthetic sound that you produce of the engine, which is the sound that can be interior, that you only hear inside, or that you only hear outside. The RNC and ANC, which is the noise reduction technologies. The ESE, which is the engine sound enhancement, when you add some harmonics to the engine sound. And the AVAS. So AVAS is basically the regulation for the exterior sound. It's different between the US and the Europe, but basically when you have an electric vehicle or a vehicle that doesn't produce any enough sound outside, you have to add a AVAS sound so that it makes enough sound and meet the regulations, basically. All right, what is the next one? Ah, yeah. Why is it needed? I mean, we could have just silent vehicles and everything will be much more quiet in the cities. But yeah, first I already described it, the safety reasons, the regulations. It's not, it's in many countries, but not in every countries, but it's in most of the countries. So all the electric vehicles that are built have this regulation anyway and produce sound outside. I think in Europe you have to produce sound between 0 and 50 kilometers per hour. Afterwards it can be cut. And that's only for the exterior sound. For the interior sound, people are free to do everything. Like Tesla, for example, they don't produce any sound inside. Yeah, then another part is the user experience. As driving vehicles, you were always, I mean, I learned driving and really focusing on the sound, being like, okay, then I have to release the clutch when I have to do that, or if my engine is really high in the pitch, then maybe I'm just too fast. And that's basically the same thing. Like you get some informations about how you drive with the sound. Then there's this audio branding thing. So in the past it was the same. Like for example, for the Porsche that I showed, it produces a specific signature sound, and the car manufacturers just basically want to keep that and yeah, have their own signature sound. So when you are in the streets, you can differentiate, for example, a Renault Zoe or this big ass Mercedes G. And yeah, then I think for me it's not the biggest argument, but it's also what is the future of the sonic environments. If at some point there's only electric vehicles, or at least really quiet vehicles, I think it's important to think about what the cities will sound like, and then yeah, have something harmonious and not have a bunch of really hardcore sounding cars. So yeah, then let's go a bit more into my domain, which is all the technical stuff, the constraints. Because obviously we do not work, I mean, there is no PC, I mean, not real computer inside the car. there is only some embedded systems like these ones, and these ones are quite limited. And yeah, coming from the computer side of programming, which is my case. I mean, I'm from the sound design, so it's even harder, but basically it makes things a bit trickier, and you have to write some codes that, yeah, can run on specific targets, optimize it, be aware of the CPU consumption, the memory usage. I mean, it's the same on the computer side, but yeah, it's harder to debug also. And you need, yeah, some time to write some codes for some targets that are, behave differently than a CPU, like for example the DSPs, the digital signal processors, and you can do, they have some accelerators in this where you can do some complex calculation in only one cycle instead of more with a standard CPU. So yeah, we mostly work with C, sometimes C++, and very rarely Rust. But yeah, it's most of the time some C. The systems are moving more and more towards some Linux and Android embedded systems. But yeah, most of the projects are still running on DSPs and small MCUs like this one. Then another part of the constraint is the security. Your codes should be, I mean, your system should not crash, basically. It would be really bad. So you have some legislations to follow. The one that I know the most is the MISRA legislation. I remember the first time that my code ran on a MISRA checker, I had like 1,000 security breaches. So yeah, it's really restrictive. No dynamic memory allocation, no implicit type conversion. Yeah, I mean, this is more for the software developers, but yeah, no non-standard libraries or functions. You need to always be careful of your pointers and have a tons of check to make sure that you never use a null pointer somewhere. Only one exit point in the functions. Also, yeah, a bunch of really restrictive constraints, which is a pain sometimes. But yeah, it allows you to really deep dive in the programming language and find some tricks with the architecture and ways to, for example, do some fake dynamic memory allocation. We're still using static allocation. Yeah. Then the scalability. The thing is, when you write some code for specific hardware, it needs to be ported in other hardware sometimes. So your code needs to still be quite using some quite standard C functions in case of using C, but yeah, it should run everywhere and be super easily cross-platform. And yeah, so one of the most famous in the automotive industry, one of the most famous legislation for that is Autosar, which have a bunch of rules. For example, the hardware abstractions, so it should allow the software to be independent of the specific hardware. Some standardized interfaces. It should have some compatibility between different components, like for example, I don't know, when you receive the data from the car, your software should not deal with all of the communication in the board. If you change the board, this communication will be different. So yeah, all of these things. It should have some kind of modular design. Again, for example, when you have to receive some data from the car, one module should be just for the receiving and the other one for the audio algorithm, for example, to keep things more maintainable and easier to debug, basically. And yeah, this interoperability, okay, that's really hard to say. Yeah, it's basically the same thing. Like it should work with different vendor software and hardware. It's again the thing of your software should run everywhere. And then yeah, all of these constraints leads to systems that are quite limited in terms of memory and processing power, and same as the video game industry. Like you don't have the full power of the processor. You have to limit everything because the manufacturer will want to put many other things on the chip. And yeah, all of these things have quite some impact on the sound design. So let's deep dive into the sound design techniques. What can be used, what cannot. Yeah, first of all, let's define the basics of it. So instead of having a remote or keyboard and mouse, you have something called the CAN bus, which are all the vehicle signals, like the RPM, the speed, throttle, the angle of the steering wheel. It can be anything, basically. Even if you power on the AC, for example, if you want to use that for your sound, you can. And yeah, then you filter that and you use it in your audio algorithm. These are basically RTPCs for the wise users. It's the same. As the computation is quite limited, usually we use the audio players. There's some WAV files looping. And yeah, the thing is, so I will just play a really basic example of that, just like a sine wavetable. And then we will get into more complex stuff. Yeah, that's like 20 seconds in my life, always listening to sine tones to debug. And yeah, to make it a bit more complex, the thing that is really used in the automotive industry is the Shepard tone. So it's basically, it was created by Roger Shepard, and it's just, yeah, exactly the same thing as this staircase, but for audio. So it's just sound that are consist of superposition of the same audio but separated by octaves, and each of these audios have their own gain and pitch curve. And it sounds like the pitch goes unlimitedly up, or if you go down, unlimitedly down. And yeah, another example, same for the sine wave, but then now with the Shepard tone. Yeah, the psychosis sound. It's, yeah, unlimitedly up. And again, so this was like an example. I think the other one we don't really care. Yeah, it's the same thing, but enough of the psychosis. Then another use is the wavetable. So as sometimes your memory is really limited, you need to use really short wave files, and this creates wavetable. So it just a few samples of audio, like I showed on. What I can use actually the this one, and yeah, this is like looped super fast, and this creates a tone. So this is one of the sessions in our, in the software that we develop, which are using, I think it's like 1,000 samples or something like that. All right. Then another one is the granular synthesis. So this requires quite a lot of processing power. So I haven't saw it a lot. We have it on our software, but if you want to go into serious production, this costs a lot of processing power. So usually they don't use it too much, but as now processors are evolving with much more power, you can do that. But yeah, this is just an example of, I did it myself. I don't do sound designs in 3 years, so please do not judge too much. It's like a 4-second audio, so it's quite short, but you can do already something that sounds decent, in my opinion. And yeah, when you don't have much memory, but you have a lot of processing power, this could be the way to go. but usually you don't have that. It's more like you don't have enough processing power, but you have a lot of memory. So yeah. Yeah, for people that are not sound designers, so granular synthesis is basically using super tiny grains of the sound. Like you sample a tiny bit of the sound and you repeat it a lot with different pitch or parts of the sound that you choose, and it creates some kind of continuous sound. And here I just move where you will pick the small grains and also the pitch of this grain. Now let's go for the tools. So yeah, the automotive industry is quite close. Like most of the tools are in-house tools or yeah, other tools that are hardly, like as a freelancer or something like that, it's hard to get actually. It's more for like big companies and you get some license from the big companies. And yeah, there is almost no open source resources. And yeah, most of the car manufacturers create their own tools or frameworks. And yeah, or use a mix of their tools and other one's framework. The most famous one is called Audio Weaver. It looks like that. It's one of the most popular systems in the automotive industry. It's actually really flexible. You can run You can run it on a lot of different embedded targets with low latency. It's super optimized, and it's a modular system where you have a bunch of blocks that you connect from to each other, like pure data or MaxMSP. They also offer an API where you can create your own custom module with some C code in there. And yeah, and you can easily see what is your memory consumption, processing consumption, and all of these things. Yeah, looks like that. And then the one I work for, it's called the EVX Suite. And yeah, it was made by sound designers for sound designers, and and yeah, it was just from 10 years of experience in this industry. The sound designers started to be a bit tired of the tools that were there. Sometimes it was just like a Excel file where you have to type the gains and stuff like that, and yeah, it was a bit of a pain. And we started to gather together some ideas on what we could do better and what would be the best, basically, digital audio workstation for the electric vehicle sound. Yeah, it's quite flexible, less flexible than Audio Weaver. It's not like block-based, modular-based when you have to, but yeah, a lot of things are already there. It's low latency, optimized by myself and my colleagues, and quite lightweight. Yeah, so I will show a session. Yeah, it looks like that. All right, let me get into my laptop. I don't know if you can see. Okay, yeah. All right, so it looks like that. Wait, why my mouse is not working? So there are a few parts: drive, control, output, and synths. So we have some kind of synthesizer that doesn't run on the embedded target. It's more like a sound design tool where, come on, I don't know why it's buggy. Okay, is there some sound? Should be some sound out. No. Okay, it's super buggy. I don't know why. Maybe my hands. Okay. Okay, yeah, it's a really basic synthesizer. There is a additive synthesis. Wait. Okay, just a bunch of sine waves that are running together. Sounds really like a spaceship, but yeah, when you add it, you have something that is more like a combustion engine kind of sound. A bunch of other stuff like the reverb, some AM modulation, some FM modulation. Not sure if these things work. Yeah, kind of resonant thing also. And another one called Prisma, which is more like a spectral freeze thing. I won't dive really deep into this anyway, but yeah, the most important is the stuff that are, for me, on the embedded side, which are the control, drive, and output section. So the control, you have like all of the CAN signals, so all of the signals from the car that are here, like load, speed, recuperation, throttle, whatever. And then you can remap it, create some conditions, like if, for example, if the gear here is between 0 and 1, then it's triggered. We also created some kind of our own scripting language where you can create more states. Like, for example, there is this thing called the kick down. It's basically when you press really hard the pedal, it's like a kick down, like it's boom. And yeah, then there is this, you would hear it. Wait, maybe I can play it? Okay. So if you are at 0, and then some kind of boom. And yeah, this scripting language just helps us to do these kind of conditions that would be hard to have in this kind of boxes. Yeah, and then the drive section, which is all the audio players that you can stack on top of each others. You can choose, for example, the inputs for the pitching. The cascading is, wait, can I have the control of that? Yeah, the load. So this is basically a crossfade between a bunch of other players that are using different wave files. You can choose the shepherd mode because you can do, I mean, there are different ways to do some shepherd sound. A bunch of different algorithms where you have like 3 layers of octaves, 2 layers, all layers, I think it's 5, yeah, exponential or linear. You have control on the smoothing, some basic EQ like low pass and high pass, and also some event players. So for example, the start here, I think it's when, wait, what if I do that? No. Okay, but yeah, basically at start it's triggered, like when you start the car it should do this sound, and when you stop the car it should also do this. No, I cannot change it actually. Okay. Yeah, and then you can have the data from the vehicle already, like all the CAN signals. You can play a CAN recording. You can emulate it with this, like as if this was like the pedal or the brake, or you can do everything manually here. Then you have like all of these sounds go then into some buses where you can tune like the yeah, just some basic EQs, some gain curves that also depends. I mean, this gain curve also depends on some vehicle parameters. And then you have the output section. So here I think, yeah, direct, but you can route things, as the car has usually between 10 and like 20 speakers. You can tune every speaker differently with a bunch of equalizers and delay and gains. And yeah, and here you have the AVAS analyzer to make sure you your sound fits a regulation. Yeah, you can choose a bunch of regulations here. And yeah, I think I showed everything on the EVX. Okay, yeah, I think I should not be too late. Then, yeah, we can switch back to the presentation. Do I still have time? Okay. All right, the future. What is the future of automotive audio? Yeah, obviously, if you have bigger processors, then you can create more complex systems using granular synths. Like if you want 10 granular synths, then in the future probably you will be able to. Right now you cannot really. Using, yeah, as you will have more memory, then longer files and things like that. Then yeah, surround sound and 3D audio, it already kind of exists. Yeah, just using some object mixing techniques. For example, for the safety, let's say that you have a car driving really close to you, but you cannot see it, then there is like some kind of safety sound that you can hear already specialized in the car, so you can know where this car is. And yeah, also some kind of acoustic bubbles where everybody can listen to different music in the same car. I mean, it sounds a bit dystopic to me, but this could be possible. I know that some technologies are working on that. Then, yeah, the usage of AI, I mean, it's everywhere anyway. I don't really, I mean, we did some research and we could not find yet some, good ways of using AI, but something that could be nice is basically use some of the user data where, like how the person is driving, and then adapt the audio depending on it. Like if he's or she are driving and really aggressively, then the sound is aggressive, or in the opposite is really calm to calm the person. Yeah, these type of things, or also create some custom sound depending on the musical preference of the people. Yeah, again, for me it's a bit dystopic, but why not? And then the interactive music, which is here for a really long time in the video game industry, but not that long in the automotive industry, as again, not too much memory, so you cannot do that a lot. And yeah, so we did some prototype on there. Yeah, so interactive audio, interactive music for the future. That was a fun project to do, actually, driving all around with the music. Yeah, so that's the end. Thanks a lot. Yeah.
Thank you. We continue with the question. Is there people in this room to have questions? We'll come with the micro.
Thank you very much. I'm here. Thank you for the conference. It was really interesting, even for people who doesn't do sound. I think like it was really good. You say that you did the Enjmin and that you work on a prototype for interactive audio. That was really cool. But I feel like the prototype maybe people may want to drive faster with the how you show it, because it was really cool. How did you do your transition from video games to automobile audio?
So it was easy in a way that already in the Enjmin I wanted to go more into the tech audio stuffs, and my end of the year internship was not about video game, it was building audio plugins. And yeah, audio development is not a really big world, let's say, and yeah, I just to be honest, it was a bit random. Like, I was not really into cars or stuff like that. I'm still not that much, but it's more like all the technical part that interested me, and go really, really low in the programming. And yeah, that was basically the transition. It was not that natural, but it worked out.
Thank you.
Hi, thanks for the presentations. It was really nice, and it's a subject which is like there are not many documentation on automotive audio, so yeah, quite interesting. My question was like similar to the previous one. What have been your first project as an audio programmer? Did you like made tool for your workflow, or like you dig in the VST developing first? And my second question is about the software made by Audiokinetic for automotive audio. What do you think of it, and is it used in the industry?
Okay, thanks. So the first question, was about, oh man, my memory. Sorry.
Your first project as
first project.
Yeah.
So at the Enjmin, I started on my free time to look into DSP development, and I just wanted to learn more. So I created a bunch of useless plugin, actually like a filter plugin that sounds like shit, but it's there. And yeah, that's how, like just having some small DSP project, like, okay, I had in mind to build a plugin, so I started to build a plugin for myself. And then in the M2 project, I mostly used the blueprint actually, but I started to do also some Wise plugins that we actually didn't use, but yeah, at least I did a bit of DSP in that, and I mostly learned everything at the internship. Like, yeah, not really at the Enjmin, because I had to work on the projects of the master. And wait, again, for my memory is so bad, I'm sorry.
It was about the software by Audiokinetic.
Ah, yes. So I never saw it, actually. I know that it's there. I know that they support the STM platform. And that's the only thing I know. To be honest, I don't know much. I know that, I mean, we were in a bunch of fairs, like the CES, and I think they were not there. So probably they gave up, I'm not sure. At some point they were there, but now they are not too much, yeah.
Okay. Thanks for your answers.
Thanks.
Thanks for the talk. Do you have any advice or resources if we want to begin audio programming as a programmer, like project to-dos or things like that?
I would say, I mean, I started with Juice, which is a framework that is heavily used in the VST, I mean, plugins development. This is nice, and there are a lot of tutorials for it. Yeah, I mean, this is for desktop development, like building some plugins. Also, a lot of books that you can find on some, yeah, not illegal but weird libraries where you can find the things for free. But yeah, like the audio programmer book from, I don't remember, Prickle something. Okay, I can send it to you if you want. But yeah, then I think if you want to really learn about DSP, you need to have a project in mind, like something that you want to do. I don't know, building a granular scenes, for example, and then you learn about how you can do it technically, and then, yeah, you just spend some time doing it. I think it's nice to have a motivation and not deep dive into some DSP topics that then you don't really apply in real life, because otherwise you will just forget about it, or, yeah, and it will be boring. So, yeah, start with a fun project where you are motivated, and, yeah, just learn how to do it.
Thanks.
Hi. Thank you for your talk, Guerric.
Thanks.
As you said earlier, you did the Enjmin some years ago, I think P16?
Yes.
Yes.
I'm old.
What were the main points? What was the bridge for you between interactive audio in automobile and video game industry? Like, what were the points where you find yourself like, yeah, this is like I did that in the Enjmin, and I can do it in automotive audio?
I think it's the building of the experience in a way that you have a bunch of inputs, and then what will you do in the output? I mean, in the video game, you have like a story to tell or things like that. For cars, it's more pragmatical, but yeah, that's where there is a lot of things that converge, I would say. Like even for the when my some sound designers that were in that work in my company started to look deeper into the musical interactive music things, as they were not from the video game. I mean, they didn't have any video game background. I was here to explain how it worked in Wise, for example, and how we could do that with our software. Yeah, I think that's. I mean, I don't know if it replied to your question, but
yes, of
okay,
course.
good.
Thank you.
Yeah, I have a last one. You mentioned like some technologies for the future was a bit dystopic. And do you feel that the automotive industry kind of feel the same, or it's like just we are going full in, and it's and like they plan to have those dystopic technologies you mentioned?
I mean, this was a personal point of view. Maybe it's not, I don't know, but yeah. I know where we go with our company. For the other ones, it's the thing is everything is quite close, so we don't really know what the others are working on. I just saw a bunch of technologies, like for the acoustic bubble, for example. Yeah, then it gets more into the political, but yeah, maybe let's talk about it afterwards.
Yeah, for sure. Thanks.